This video is done by Group 7, Nicholas Wong, Su Xiao Hao, Ernzi Ming, Tang Xuan Min. Before our group begin the crawling, we proceed to obtain a list of keywords regarding food and restaurants from Yelp website. In total our group obtained 77 unique keywords. The full listing of the keywords can be found in Yelp API Crawler project. Our group has written a web crawler that was built using Java programming. It uses Yelp API to access Yelp database using the standard and secure protocol. This crawler will loop through each keyword and crawl its information and return attributes such as name of business, URL of restaurant, city, postal code, latitude, longitude, location and several more attributes. The crawled information will be saved in a single text file. The crawled dataset will then go through a JSON formatter which will check each record category to ensure it is either restaurant or food, otherwise it will be discarded. The formatted dataset are now ready to be indexed. For indexing we chose to use SOL. In order to perform indexing our group modified the schema.xml to include all the fields in the formatted dataset in order to pass it data to the indexer. Our group had chose to declared categories, id, location to be indexed. Copy field declaration are also included in our schema. Copy fields are used to instruct SOL to duplicate any data in the source field to the destination field of the document. Users are only allowed to perform searching on these declared copy field. Our group also made use of whitespace token as a factory, lowercase filter factory and edge n-gram filter factory. The indexed dataset are now ready to be queried using the user interface. Our group chose to develop a web-based UI using JSP for querying the data. The data will be retrieved from our Parquet Sol in JSON format. The web page will consist of a simple text box to enter the query and a search button. In addition, the web page shows the nearby food and restaurant of the user. This is done by exploiting geospatial data which retrieves the IP address of the current device and locate the user latitude and longitude. This data will then be processed and calculated using the haveassign formula to get the nearby locations. The text box has an autocomplete feature which will process the query and return partial results according to relevance. The search query will also be bold to facilitate the user in viewing the results. Upon clicking the result, the user will be redirected to the full page review of the selected item. The user can also enter a query and click on the search button to view a more comprehensive result page. The user will be able to see the number of records found, time taken to query and also sort the results by name, relevance or ranking. The video will now show 5 queries with the number of records and time taken. Similar to the autocomplete, the user will be able to click on the link for the full review of the item. In this classification task, our group performed sentiment classification task on food reviews dataset using K software. In this task our group manually labeled 500 records into either positive or negative review. Our group decided to label 500 records instead of 1000 records because each review can be very lengthy. Here shows some example of lengthy reviews. The classification was carried out by performing some text pre-processing tasks such as stop word removal, stemming or attribute selection. Then for each pre-processing we proceed to run various classification algorithms such as naive Bayes, KNN for validation phase. We used tenfold cross-validation. When performing classification we load in the dataset that had already been pre-processed. In this demo we only shows an example of performing the classification using naive Bayes. Here show the full listing of the results. From this 4 datasets, it shows that naive Bayes are the best algorithm with highest accuracy and F measure. Food Review 2 and Food Review 3 have the best pre-processing step.